intellectual firepower imaginable. And I'm going to be short and I'm going to get out of the way quickly. I wanted to first kind of set a couple ground rules. Our first presenter is going to be José. He has a flight he needs to catch, so he is going to leave as soon as he's done presenting, and he will be represented by Kim on this panel. We have set up the panel to be a short one. We're looking to keep it within a half an hour because the panelists decided that they would like to riff a little bit together once they get done and have more of a free-form discussion. The way I like to structure it is if you have a question at any point, please raise your hand, I'll nod to you, and when we get a couple questions set, I'll try to interrupt the riffing and get those questions in. I just wanted to say two things before I get started. Each panelist will introduce themselves. One is that this issue of terminology of energy, I hope everybody realizes that a therm, a BTU, a CCF, they can all be converted to a kilowatt hour. It's all just a unit of energy. And NY-GEO made this point in 2018 in testimony that we filed with the Public Service Commission. It was a 53-page paper. This was recommendation number 12, that we unify around the notion or around the terminology of a kilowatt hour because we are moving to electrify, and it's going to be important for people to be able to compare and to get a sense of things, basically using the same unit of energy. The last thing I'm going to do is this morning when Vicky Kuo was going to give her presentation, I looked at some of the notes in advance, and she didn't ever get to this, but she was going to tell you about how much energy Con Ed has saved on the electric side, which was 2.9 million megawatt hours, and how much they had saved on the gas side, which was 79 million BTUs. How many of you in this room thinks you know which is more units of energy? Exactly my point. We should be able to compare these kind of things. It's going to be really important as we look at efficiencies, that we look at demand reductions. And just by the way, it's the 2.9 million megawatt hours. The 76 million therms is 2.2 million megawatt hours. But we really need to be able to think in the same terms and to be able to compare and think more clearly about our energy choices moving forward. And this panel is going to help you do that. I would like to call on José to get us started.
Thank you, Bill. And thank you for your understanding. I'm sorry and apologize also to the panelists for me having to leave right after. So I'm José Acuña. I am an advisor and a researcher at KTH in Sweden, dealing with ground source heat pumps. And I will tell you with a few slides how we actually use kilowatt and kilowatt hours as the standard for communicating and understanding this technology better. I will start by just telling you how the Swedish market has evolved in terms of heat pump sales. The one interest for this conference is the orange bars, which represents water-to-water heat pumps. We sell about 20,000 units every year. And all of these orange bars together deliver about 29 terawatt hours per year in thermal energy. The installed capacity of these altogether is about 8.2 gigawatts. And I have done a quick translation to that. The energy unit 29 terawatt hours will be 100 trillion BTUs, and the power 8.2 gigawatts will be 2.3 million tons of refrigeration, just to put it in your own units. So this is thermal, and for us in Sweden, as I show in the rightmost column in this table, you have energy and power units. And for energy, both thermal and electrical, we use kilowatt hours or megawatt hours or terawatt hours, as I showed before. And for power, we use kilowatts or megawatts or watts. As a difference from that, you have in the United States, for energy, you have BTUs for thermal and kilowatt hours for electrical. And in terms of power, you use tons of refrigeration, BTUs per hour, MBH, and then kilowatts for electrical. So there is kind of a contradiction in terms of when you use heat pumps that actually deal with both heat or cold and electricity, you really want to deal with the three energy flows in the same unit so that things make more sense. And if you look at a typical water-to-water heat pump system in Sweden, it looks pretty much like this most of the times. You have a loop that delivers cold on the lower hand side, illustrated in blue. Then you buy electricity, and this is the black arrows, and then you have the loop for the heat distribution in red. And blue plus black is equal to red. That's the balance. In terms of cooling, you have the scheme to the right side, and then you produce cold, is the blue arrows. You buy electricity, black arrows, and produce heat. And the sum of blue plus black is always red. So this is the nice thing about heat pumps. We have an energy balance that is always there, both in an instant of time and over time. So the three blocks on the very bottom, blue plus black equals to red, cold production plus electricity equals heat production. And this balance allows us to work with the COP for heating, which is the quote between the red and the black, and for cooling, the quote between the blue and the black. So for this, having the same units makes the world very much easy for us. Electricity is the one that normally people talk about, but we really want to talk about how much thermal energy actually this technology delivers, because that's the biggest block, both in terms of power and energy. So for us engineers, it's very useful to work in these units. For example, you have, for example, on the top right side, a chart showing the hourly heating demand of a standard residential building. And if you see, the power changes at every hour, of course, depending on the climate, but it's very convenient if you just group these points in a graph like the one I have on the top left, bottom left-hand side, where I group the powers and the amount of hours that each power is needed. So in this case, 0.6 megawatts, which is the largest power, is only the coldest day, and that happens pretty much 0 hours per year. And then you can see at each point in that curve how many hours per year each power is needed. So when you can see power in kilowatts or megawatts in the y-axis, and you multiply it by the hours, then you have energy. So it's very convenient. Power times energy, power times time equals energy. And that's actually the area under that red curve. So if you see, it's kind of a triangle, and that will be a triangle. So if you could do 0.5 megawatts times 6,000 hours is 3,000 megawatt hours divided by 2, because it is a triangle, then it's 1,500 megawatt hours of energy demand. So it's quite convenient because the megawatts and the megawatt hours give you quite a lot of information. And if you divide that by the COP, if this is delivered by a heat pump, then you have the electricity. So it's a very useful unit. Another aspect is that the y-axis of this chart is the installation cost. Normally, the installed power that you decide times the price per installed ton of refrigeration, or installed megawatt in this case, is the installation cost. If you multiply it by the amount of hours, then you will have the running cost. So this type of graph gives us not only a very good technical base, but also information about the life cycle cost of installation. And when we want to compare them with other technologies, of course, we put them. You see price of electricity on the bottom and the price of the competing technology on the left vertical axis. And then this helps us, if they have the same units, to quickly plot. For a low price of electricity, perhaps it's better to choose electric boilers because the electricity is so low. For low prices of the competing technology, most likely you will choose the competing technology because it's cheaper. But for systems where both of them are relatively high, then the ground source heat pumps or heat pump systems are, of course, a very wise choice. And these prices, of course, sometimes are per kilowatt. Sometimes you pay per installed power and per energy use. And these two can be also combined in such diagrams, actually. My last slide is this one, and this is statistics from the energy use for heating and domestic hot water in Sweden in the last 40 years. And if you remember the previous chart I showed with the heat pump sales, we have sales, very stable sales of heat pumps also for the same period. So what this chart shows is that the actual heating energy has decreased over time in Swedish buildings. That's because we have phased out the oil, the district heating has taken higher market shares, electricity has actually decreased, and this is of remarkable character because, as I told you before, heat pump sales have increased over time. So lots of heat pump sales, but less electricity use, and this is because most of the systems that have been replaced are actually electrical boilers. However, the most interesting thing about this graph is this area over here. We are thinking here that the demand has been decreasing, but that's not true. The demand actually has increased according to this dotted line. And that's because we have built new buildings and because we use heat pumps that deliver invisible energy. And that's the thermal energy that I told you in the previous slide. So this whole area is actually free renewable energy from the ground, from the air, exhaust air, and so on, delivered by heat pumps, but not shown in the statistics. So my take is show more of the thermal energy, preferably in international units, kilowatt and kilowatt hours, and then we will actually show how big contribution we're doing to the society. Thank you so much.
Sorry, this was not the planned order, but what the heck? Where's the thing? Here it is. Okay. Yeah, first of all, let me say, I know it's the last of the day, which explains partly why there are not that many people here. But it's important to understand, this is going to sound a little weird, but this is actually I think one of the most important presentations that we've had, other than the leasing one, because this question of which units we're using determines how the industry presents itself and how it will be presented and talked about by others. One of the big problems we have right now is you can go out and you can find vast quantities of information about the number of gigawatts and the rest that are produced by solar panels that are on people's roofs. You can find nothing about how many total gigawatts of energy are being produced by being harvested out of the ground by geothermal heat pumps. You just can't find it. So right now, geothermal heat pumps don't end up even in the conversation about renewable energy because they're not measured in a unit that makes sense to anybody who's actually in that business. A bunch of engineers can sit and they can do the calculations and the rest, but the people that gather the statistics, you can't take kilowatts and tons or fortnights or whatever it might be and combine them together in a database. It just doesn't work. I've been in the computer business for a long time, and I can tell you, you cannot mix these things. So anyway, this is what the world looks like in terms of who uses what units when talking about stuff, and it's a little bit hard to actually understand. But the red blob up there in the upper left, of course, that's us. The rest of the world is green. There's that sort of weird slash of yellowish there. I'm sorry about the color choices. But it turns out in most of the rest of the world, the green areas, they all work in kilowatts and kilowatt hours. Okay, they use standard units. In that sort of yellow group there, Southeast Asia and the Middle East and such, they'll typically they'll use double units on their nameplates. They'll do standard units, kilowatts and kilowatt hours, but also horsepower, okay? So you're thinking like, why in the world would you use horsepower as a metric for your air conditioning system? Well, it turns out a horsepower is about 3/4 of a ton. So, so actually horsepower turns out to be a more precise measure of the energy usage of an air conditioner. If anything, if we're not willing to go for kilowatts and kilowatt hours, we should probably convert to horsepower because it's a better measure and a more precise measure. But the solution here actually is forget horsepower. Let's do what the rest of the world does and deal with kilowatt and kilowatt hour, because that's what everybody does here in our country too. Anyway, just the case for kilowatt hour and KW and KWH, federal law is all determined in terms of KW and KWH. If you look at section 48, okay, section 48 tells you that if your system is greater or less than 1 megawatt, okay, that determines what your tax credits will be. Well, okay, if you're a heat pump guy in America now, you're saying like, what the heck is a megawatt? Because I've got tons and I've got BTUs and I've got all kinds of other strange measures. But it turns out the law is all expressed in megawatts, not in BTUs or tons. All the grid response, when we go to, say, NY-GEO and we say, oh, you know, we've got so many tons of air conditioning capacity or whatever, the NY-GEO guys sort of scratch their heads and say, what the heck is a ton? Okay, and how do you spell it? Is that T-O-N, or is that one of those T-O-N-N-E-S things that the carbon people use? Like, what is this thing? They have no idea how to think about our systems in their context. Consumers get confused all the time. Consumers have like this vague sort of gut feeling of what a watt is and what a kilowatt is because they pay for them. You know, they're like 20 cents, 26 cents for a kilowatt. You see them on your bill at the end of every month. You know that when you turn your electric lights on, you're using more kilowatt hours. You turn them off, you're using less. So you have an intuitive sense of that is, when was the last time you found a consumer who had an intuitive sense of what a ton is? Or a BTU, okay? They don't exist. A bunch of old farts with gray hair, you know, who like play around with HVAC systems and, you know, that sort of thing. They understand what these things are, but normal human beings don't understand what they are. Anyway, we can go on. All the regulatory system. You know, you look at FERC orders, you look at local law 97 here in New York City, the section 48 I already mentioned. All of that is measured in kilowatts and kilowatt hours, not tons, okay? Here in Maryland, in Maryland, they have GREC markets. You can get geothermal renewable energy credits, okay? They're geothermal renewable energy credits. What units do you think they're measured in? Are they measured in tons and BTUs? No. They're measured in kilowatts and kilowatt hours. Of course, because why would anybody do anything else? Same in Virginia, same throughout PJM, New Hampshire. Nobody uses these things except for the old guys in the geothermal business. My contention is the market has decided we should be working with megawatt hours and megawatts, not the silliness that we've got now. I'm running out of time, so let me just skip ahead to, you can read these slides later. The most important thing here, maybe to one extent too, is just think about this. We're looking forward to the future where we're trying to electrify all our buildings, and we can be confident that it will happen. Maybe it won't happen next year, but maybe 10 years from now, 20, 50, 60, 100, 200 years from now, we will get rid of oil and gas. We will get rid of this business of burning stuff in our basements to heat our homes. We will have electric homes. And in those days, think about your grandchildren and your great-grandchildren. If they go down and they look at their heat pump and the thing is measured in tons and BTUs, they will have no idea what that is, because there will be nobody who has, you know, you're going to say it's relating to the amount of energy that's necessary to melt a 1-ton block of ice, or like some of the units we use are determined by the amount of energy given off by lighting a match. I mean, this is just craziness. We're going towards a world where we're electrifying. We should be talking in the language of electricity, okay, which turns out to be the international standard for how we talk about energy. And we talk about energy in kilowatts and kilowatt hours. Stop embarrassing ourselves for our children and our grandchildren. You know, let's get over this. Understand there are many, many more real people in the universe than there are old-time engineers who grew up with BTUs and therms. It's time we caught up with the rest of the world so we can make it easier for them to catch up with us. Let's be like cool kids and use the lingo of the day, right? There you go.
Can you hear me? Yeah, okay. I'm Mark Kleinginna. I'll give a very short introduction. I work for Emergent. Oh, I'm not Bob Wyman. Not today. Short introduction. I wish I were the old fart with gray hair who was doing this. I don't have any hair, so it's, you know, kind of like that's the way it is. But I am an old fart. My company is Emergent Urban Concepts. We do a lot of work around the energy business and the energy transition. Had the opportunity to work with Bob Wyman 10 years ago in an intervention that he did and we did at National Grid in their rate case. And I've worked with Zeyneb for quite a long time. So the topic of the presentation here and what I really wanted to talk about was measuring units and being very clear, and actually José kind of teed it up. So the demands to be energetic. So we're going to talk about demand and energy, but the important piece is demand, not necessarily energy. So we want to measure in kW, not kWh. Now you would say, well, why would you want to do that? And I'll start with this. So this is a quote yesterday made by someone who works for the company who's providing the gas and electricity to this building, and what he said was everyone last year was talking about tens from the natural gas utilities perspective. Now we're all talking about tens from the grid side, the electric grid side. So what's the grid side measured in? It's measured in kW and in kWh. So how do we design the electric grid and why is it important? Well, the electric grid is sized to meet local and regional instantaneous design day demand, expressed in kW, okay, or MW, megawatts. Thermal networks provide an unloading of the electric grid locally and regionally. That's pretty darn important, and I think we understand that. The payment for electric generation capacity at the ISO level, regionally, is made in dollars per megawatt year. The payment for electric transmission capacity is made in dollars per megawatt month on an ISO network transmission basis. The payment for electric distribution capacity is made in dollars per kilowatt month. Okay, and so what does that mean? That means that what people see on their tariff, what people see in terms of translating what the thermal network unloads is expressed in dollars per megawatt hour. So this is why this is important. So it's important that if we want to do this, we've got and get those rents associated with unloading the electric system, we've got to talk in terms of what's happening on the electric system. Okay, so beat the peak, actually the design day, you know, so we said this already. The biggest value proposition NY-GEO members need to work on is reducing peak electric demand. What is that measured in? kW. That's what's key here. What's next? The only way to monetize the value of this, the only way to monetize this is to the grid is to get paid in dollars per kW. Our crack at that pot of money, okay, we need to work all the way back through from the electric meter all the way back to the nameplate capacity of the units we're installing, all the way back to the nameplate capacity of the borehole, all the way back to the nameplate capacity of the thermal network needs to be in dollars per kW. It's the only way we get a crack at that pot of money, which is so important. So if we imagine the grid as this bathtub, okay, we need to do this in terms of kW and do it in terms of a common units, not this back and forth. And I'll tell you, I made a heck of a lot of money one time by being able to understand what a heat rate is. Okay, for those of you who are in the electric generation business, you may or may not know what a heat rate is. But basically, it was a conversion of how many BTUs does it take to make a megawatt hour, or how many MMBTUs does it make a megawatt hour. And you had to do that math in your head, and a 10,000 heat rate machine would run this way, and an 8,000 heat rate machine would run this way. Let's forget all that. Let's just make it in terms of how efficient is it. Oh, it's 50% efficient. That doesn't need to translate into a 6,800 heat rate, right? We can just say it's 50% efficient. A lot easier. 2 minutes, all right. But why doesn't the energy matter as opposed to the demand, kWh versus kW? Okay, only to the extent that costs across system are caused by annual energy versus design demand, okay? The only reason that you would worry about kWh is if you were concerned about what happens annually across the system. But that's not what causes costs. What causes costs at the distribution level for the electric grid, at the transmission level for the electric grid, at the generation level for the electric grid is primarily demand related, okay? The same thing is true on a thermal energy network. There are some costs that are energy related, but they're really pretty small. And the majority of costs that are in the system that are energy related have to do with fuel costs. And we're getting rid of fuel. That's the beauty of this. So kW across the system will provide the ability to get at those rents and reach that pot of gold. I think that's it. That's it.
Well, it's hard to follow a pot of gold. And as the last person, I get to be even faster. I do want to tell you that this panel was initially pitched to me as a really fun fight between people who care, who think it should be kilowatt or kilowatt hours, and people who want BTUs. But then when we met, no one wanted to take the side of the BTU. So maybe there's someone out there who's going to make this a little more fun, but there was near universal agreement, so you're just getting a lot of arguments for why we should all do the same thing. So I was looking at stakeholders and really see this as a win-win. It might seem a little esoteric and maybe in the weeds or wonky to talk about this, but when it comes down to it, it actually has the power to drive transformative change because it makes it a little bit easier for a whole lot of stakeholders in the energy system, and that matters a lot more than you might think. And so I'm going to give you a quick example with a neighbor's energy bill. You asked if there was, someone earlier said, is there anyone who actually knows what these units are outside of some people in this room? And it turns out my neighbor in Cambridge, and thought that they were using about the same amount of energy on their gas and their electric bills shared here for the month of October. One was 28 therms and one was 25 kilowatt hours. Right, see, we got one laugh. So just quickly converting, so a therm is 100,000 BTUs and 28 therms is therefore 2.8 million, which is 820 kilowatt hours. And so it looks the same to my neighbor, but it is actually 32 times the energy, which is, a challenge for people's understanding of their energy and also how to switch technologies. So when you go to switch technologies and you say, okay, well, let's electrify you. Well, if you take all of those kilowatt hours and make it electric, that's going to cost a lot. But of course, you have to first account for the efficiency of that gas boiler that they have, and then look at the efficiency of the technology you're switching to. And suddenly, you've got somewhere between 969 kilowatt hours and 646 kilowatt hours for the same amount of energy, right? And so the facility with which people, and no one's going to do this. None of my neighbors are going to do that. Well, a few in Cambridge, but the facility with which we switch back and forth, and I think this point has been made a bunch of other ways, and Jose made it first. It really matters for people's understanding of purchasing and decisions, but it also matters at a kind of integrated policy and planning level. And things like, for example, there's a commissioner who's looking at, can we meet an RPS on the electric grid by building thermal energy networks and having the energy savings to the grid account? Well, again, same units would be helpful, and understanding where and when and which technology we electrify, having all the units the same, again, helpful. It's complicated enough without different units. And actually I thought of another, Bob gave so many great examples of policies that are already kilowatt hour. There's another one, which is the standard and long negotiated boundary for union versus non-union, a megawatt, right? That, no one wants to renegotiate that in tons, trust me, not gonna happen. So coming to, I think what's maybe everything else has kind of been said, but since we all agree, and there's a whole bunch of reasons across the board, and since the whole rest of the world, as Bob said, and also the whole rest of the system is already there, how do we actually go about doing this? So I'm turning it over to you guys to have this conversation. My first proposal is, first, we start with ourselves. Change always starts with ourselves, so we get all of the GEO orgs aligned around switching, make it a thing, a movement amongst ourselves to begin with. We get the Office of Geothermal at the Department of Energy on board as well. Then we integrate the units into legislation across the country with networks of advocates, and we write a clear and simple white paper for regulators to begin moving it into regulatory hearings. And then systematically identify policies or programs where we need to update. I think it'll actually be easier than it sounds. And I really believe that it will have much more payback in terms of, yep, I'm good. I think it'll have much more payback than I have a way to estimate. So that's it. We got to do it now. I'm done.
So as I mentioned, this is an incredible panel. I don't know how much folks realize the impact the folks at this table have had on the geothermal industry and the thought leaders that they are. So we're going to give them a chance to kind of riff a little bit, and they might even talk about something different from kilowatt hours. But if anybody has questions, please raise your hand. I will nod to you when I see that, and when we get enough of them set, I'll kind of interrupt the riffing. But go to it.
Bill, if I could just follow up on what Zeyneb said, like, how do we move forward from here? I think one of the things we're going to do is talk to the manufacturers. Oh, goodness, there's like the president of one of those organizations. He's sitting right there. Oh, I'm sorry. But if we went to the manufacturers, don't you listening, JT? We went to the manufacturers and we said, hey, come on, could you, on your nameplates, could you at least double mark these the way double mark them the way they do, for instance, in Pakistan and Southeast Asia and the rest. If you really insist on having BTUs and tons and whatever, could you please give us some KWs and KWHs right next to them? And the minute we had nameplates that had the units on them, we could start moving forward. People would start realizing, oh, look how easy it is to do these calculations. So if we just get a couple of them, that might help us a lot.
I totally agree with any volunteers. And I actually, while preparing, was wondering, because BTU meters are so expensive here, when we've looked at them and put them, for example, in Framingham and other thermal networks, looking at rate making was the first geo utility rate case in commission right now. I wondered and it turns out it looks like they are. But you can get different nameplates. I mean, I think the nameplates would be a place to start.
So I'm filling up José's position here, but thermal energy and electric energy measured in the same like kilowatts and kilowatt hours would be great. And also, the experience from the Nordic country is you saw that José showed how much we're getting free energy from the ground. And we are somewhat good at telling the market how much that is, but it depends on how much we have on heat pump statistics and how many boreholes are drilled. But we're going to sell geothermal to everybody in the US, like what is our industry doing? So we need to stop measuring that, because we're only measuring the cost today. We don't measure the revenue side of the profit and loss.
I wonder if we could ask, is there anybody in the audience who would like to defend tons of BTUs?
Get rid of.
Somebody get them a man who wants to defend tons of BTUs. Give him a mic. Who's got the mic?
You got the mic. Oh, you want to defend it? Use AI and stuff.
This silly thing.
Eric Ryan, jeweler. Not necessarily defend BTUs, but the kind of elephant in the room that I think is getting ignored right now is if you're going to talk about kilowatts in thermal, you need to talk about temperature in Celsius. And if we're looking at performance specs or things like that for contractors and installers, that's a much bigger leap than saying, hey, it's kilowatts now. It's no, Fahrenheit doesn't exist either. Any thoughts there?
Yeah, I think replacing
Joules, yeah.
BTUs and tons with kilowatts and kilowatt hours and stuff is a lot easier than getting people to give up on Fahrenheit. And it's less important to the industry. The important thing for the industry is that we be able to say, your solar panel produces energy by harvesting from the environment. My heat pump produces energy by harvesting from the heat pump. You do so many kilowatts and kilowatt hours. I do so many kilowatts and kilowatt hours. We're talking the same function here. Don't think your panels are weird or any different than my stuff because they do kilowatts and I do tons, okay? We're both methods for harvesting energy from the environment. We should be talked about in the same conversations, aggregated in the same national statistics, tracked by the same Census Department in the same tables, discussed by Wall Street in the same conversations, because we're both pulling kilowatts and kilowatt hours from the environment using harvesting technology. And Fahrenheit, yeah, I spent a long time living in Europe. I've spent a long time living here. I can give you the story on both sides, but it turns out it just doesn't matter in terms of, I think, the important policy issues for this business. What matters for this business is KW, KWH, not Celsius versus Fahrenheit.
I was just going to say, it's pretty simple. If you want the money associated with the capacity, you got to express it in the capacity that it's measured in, and it's really that simple. No one at the ISO is going to convert to BTUs or MMBTUs per day or anything like that. The bottom line is that the ISO cares about kilowatts, and the bottom line for the rest of that is if you put it on the nameplate, then for a knucklehead like me who's trying to figure out how to measure that so that I can actually say it's a resource on the system, then I can say, oh, I've got this much capacity coming onto the system as a heat pump in this place. And that's very, very valuable, very helpful.
Zeynep, we're reaching a critical mass with questions. Why don't you go and then we'll start with the audience.
Absolutely, okay. And I just wanted to pick up that kind of sense of an amount of energy that people have, and what Kim said earlier. We have a huge handicap in geothermal heating and cooling where we don't quantify and put on bar charts the thermal energy that we're capturing and moving. Same with an air source heat pump. And any heat pump, when we look at energy plans for a country, they say solar capacity, wind capacity. No one ever puts a bar for the amount of thermal energy in the space around us, or the amount of thermal energy we're using with every heat pump deployed, or capturing and moving. And we're trying to do a project to figure out how to kind of create a standard way to quantify available thermal energy in the ground and the space and the rivers and so on around us, to try to name it, and naming it in a unit that makes sense. We commit to that. So we'll be naming it in kilowatts, right, Arjuna? Okay.
Great. So I just wanted to say that the paper that I mentioned originally, the testimony that NY-GEO gave, if anybody wants a copy of that, I'd be happy to send it to you. See me when we're done, and we'll exchange emails. We're going to go Gino, the gentleman in the hat, and then Brendan, is that, and then Pasquale. Those are the four.
Bob, looking at your map of the world, that was before 1975. After 1975, Canada became switch hitter. They basically not only had kilowatts, but also had BTUs. And so we were forced in Canada to go with a metric system against our will so that we can deal with the rest of the world as well.
I believe in Canadian independence, and also as we think about this, this is our 250th anniversary of independence from Britain. Let's get independence from British thermal units.
I know, right? All right.
Is there anything to learn from the switch to Canada to make it easier for us?
It was hard.
Yeah.
Most of the people didn't want it.
Mm-hmm.
But the thing was, the rest of the world is kilowatts and
Mm-hmm.
but the government at that time had a majority, and it cost us a lot of money, and but it was worth it.
Let me just add something here.
Your name and organization?
My name, sorry. My name is Chester Birchwood, and my organization and my company is BK Climate Solutions. We do air-to-water heat pumps, and we also do geothermal, shallow field geothermal. One thing I want to say is that some of our equipment comes from Europe, and in Europe, everything is kilowatts. And to me, it's easy because I know both, and I can switch it in my head. When I was doing some work in Montreal, it's so interesting that the architects was giving me stuff in BTUs and kilowatts. And you know why? I'll tell you why. Because Americans was coming from Vermont to buy property in Montreal. And that's what happened. So they kept the BTUs in part of Montreal. Anyway, but what I'm thinking is that what NY-GEO need to do is to go to the classrooms and educate them right in the classrooms, because kids, when they learn something, they educate their parents. And it also influences the way how they think about energy. So if you go to a classroom, even an elementary classroom or even a junior high, and they talk about geothermal energy, and they start mentioning about kilowatts and how much power it's used, because the children's mind, are open. And they will actually educate their parents, and their parents will say, you know what, and they'll educate others. It's a kind of a low-brow way of just getting in there, because look at advertisers. Anytime they want something to change, what they do, they target the kids. That's what they do, because the kids will open their mouth, if they like something, they'll talk about it, they'll get interested, they tell the parents, look, let's try this. So even if the politicians don't want to change, or the hardcore engineers that's entrenched don't want to change, or even UL, or even whatever organizations that does that don't want to change, then you go straight to the classrooms and you educate them about geothermal and keep talking in, not in BTUs, but in kilowatts, and show them how practical it is, and then the kids will go home and so disseminate all the way to their parents start talking to others, and I think that's the approach it's supposed to be.
If we have to do that, we should. But frankly, we should try our not to, because there's so many important things that we want to put in the minds of our kids. There's so many important things we want them to learn. Why in the world would we want them to learn the difference between a BTU and a kilowatt or a kilowatt hour? And why would we in the world would we want them to use their energy to tell their parents why one is better than the other? For goodness sakes, let's not even teach those kids about fortnights and hogsheads kilowatts and kilowatt hours so they can have simple systems to move forward in their lives. Let's hope they never get exposed to this issue, if nothing else, because it will be embarrassing. When they realize what sort of silliness their parents and grandparents have put them through, they will be sitting there thinking, I always knew those people were idiots, and now we have proof.
I'm just hearing this and thinking, you know, the task of switching to metric or to switching to Celsius is massive because people have a kind of learned, lived experience, the children and the adults, of like what a temperature means physically to their body. But almost no one, like a tiny, tiny countable handful, have an actual sense of what the units we're talking about are. So our barrier to changing this is really, really small. We don't need to re-educate because people don't know already. And I think that's a huge advantage, and yeah, I'll give up.
Good. Brendan.
Yeah, Brendan with MCOR Bethlehem. So as a kind of aside of that, you know, I'm a more recent graduate of engineering school, and we basically didn't touch SI units, or we didn't touch stupid units at all through college. Everything was SI, and then immediately upon graduation, it's like, nope, everything is in English units, antiquated units. So as kind of a dovetail to that is the question of how do we, because it's not just the geothermal industry. You know, we're a mechanical contractor. We primarily install, you know, standard gas and heat pump systems. I think the industry is much larger than just the geothermal industry of heating and cooling in general. And, you know, in order to complete this, you know, massive switch over to thermal energy and geothermal systems, those contractors will need to come along too. And how do we, you know, bring along not just the geothermal contractors, but get all of the other mechanical contractors to agree and move that direction.
Before anybody responds, can you just explain what SAI is for the audience?
Metric, System International, essentially metric units.
Yeah.
Sorry.
Pasquale?
So as inspired as I am to hear about the possibility of certain manufacturers who'd like to be on the pioneering edge of this new expression of energy in terms of units, kilowatts, I would suggest that we look at the regulatory agencies, and like ARI, not regulatory, but rating agencies like ARI and the Public Service Commission, to speak in terms of not one or the other, but the first step is to get them to commit to the conversion into kilowatts and kilowatt hours. So we do have, you know, for those who haven't noticed, there are some cultural conflicts. There's a lot of emotional aspects to making these kinds of changes, but I would suggest getting it onto the nameplates as a first step from a rating agency so that it's across the industry. And then if there's a particular manufacturer who would like to jump ahead, all the better.
Great. Thank you. Any other questions or any riffing from the panel here?
I was just going to pick up that, sorry.
Long days, Zeyneb.
You know, it's true that there's a whole lot more in the heating and cooling space today than geothermal. But why is that? And what happens when we look forward to the future? I think in many other presentations we've had, you know, over the last 2 days, it's been probably made fairly clearly that because of the efficiencies of air source systems, because of the importance of KW demand to the grids, the air source systems just aren't going to work. Okay? We're just not going to be able to have 100% penetration, large penetration of air source systems in 2050. So the reality is that we may be a small industry today, but we're going to be the majority, we're going to be the dominant industry in the future. We have no choice. We cannot build a soon-to-be obsolete air source systems. Most of them are being built overseas in places where, frankly, they are much more comfortable labeling NSI units than they are in English metric. Every one of those Japanese systems that comes in here, every one of those Chinese systems that comes in here, that was originally built to KW and KWH standards, and it was only some guy deep down the bowels of the company somewhere was told, go figure out these calculations to put together these strange nameplates for the Americans that are different from the nameplates we put on exactly the same hardware that we ship to every other country in the world. So the people that are making all that other equipment are primarily coming from overseas, and they work with SI units all the time. With the Americans who produce that equipment, they ship overseas and they work in SI units all the time too. They just have the funny little labels that they use for the U.S. market. Most of the geothermal heat pumps we have in this country are made in this country. So we've got a lot of control and a lot of influence over what happens in this country with our geothermal heat pumps. And if we understand that important point, is that this technology will be the leading technology in 2050. It's time that this industry started to lead, because it's just positioning itself for its inevitable role in the future.
I totally agree, Bob. I also remember what was my idea from before, which was to the point of all the rest of the thermal industries. And I was thinking, rather than saying it as leadership, I was thinking that, if we succeed by leading, starting with manufacturers in this, the geothermal industry committing to this, if we succeed at monetizing the electric grid impacts of the efficiency of geothermal heat pumps, it seems very likely that air source heat pumps will follow and attempt to monetize their efficiency as well. So why worry about that? Let's just do it ourselves, get to Mark's pot of gold. I know they're less efficient, but they're still more efficient than a gas boiler.
But this is the cool thing. If we can carve the air source guys into putting KW and KWH nameplates on their machines, they'll never sell another goddamn unit. Okay? Never again. Because when people can look at it, and they can look at, this is electricity, this is thermal, this is why are these numbers so big? Okay? Like, why is this KW unit on this box so much bigger than the one on that? Oh, because that's the air source, and this one's ground source. Okay, if we can pull this off, okay, it's a self-fulfilling prophecy. We will be the leaders because the moment the air source guys start using KW and KWH, it's game over.
Any other questions? JT?
Yeah, I think you just made the argument of why the industry won't shift, Bob. No, don't let me finish. Just hold on. Curb Your Enthusiasm. Was that a TV show? So I think that's one very valid and gravitational point of why the air source heat pump industry may not be motivated to convert. I'm going to take a risk of being publicly wrong here, but is anybody on the panel sure that ISO KW ratings are not on ground source heat pumps today? They're on some.
There are some, but not all, nameplates today. And whether or not they're there, the industry, in terms of its practices, in terms of its collateral, in terms of its marketing material, training, and all the rest, it still uses, in the United States, it still uses the British units. It doesn't use the SI units, even if the SI units are known and are published.
Mm-hmm. So I'm not taking sides on this argument. I'm foolish, but not foolish enough for that. It's like, and I think it parallels back to the Fahrenheit Celsius discussion. It's miles and kilometers, it's meters and yards, it's all those things. And so I think if the objective is to accelerate or progress towards that, I don't think there's a strong argument against it. But the reality is there's two elements to it. One, we can't do that unilaterally. The ground source heat pump industry can't do it unilaterally. AHRI and ASHRAE are the two critical standards organizations that have to be influenced because they have governance over all ratings, all standard, all performance criteria. And so that's where the influence has to happen. I guess my last comment I would make is 5 years ago, the ground source heat pump section or water source heat pump section in HRI was initiated by HRI to actually establish and parallel their standard with the ISO 600 standard. And I believe, because I tried to call Bob Brown, who is my technical brain, to confirm. Bob wasn't available, but I found a nameplate just Googling that has ISO KW ratings on it for ground source heat pump. I'm not saying they all have them. I'm not going to say that until I validate that, but I think it might already be there. So I think we need to do some validation, unless you've done the research, Bob, and you know they exist on some and not on others.
They exist on some and not on others.
And is there any product categories that define that, or it's totally random?
They exist on some and not on other ground source heat pump systems.
Okay.
And I don't want any names.
That's fine. No, that's fine.
The point is, even if they're there, even if we're successful in getting them all, at least for the U.S. Ground source heat pump systems to include the SIUs, then I think we need to start backing up into the rest of the ecosystem and publishing in product documentation, in sales materials, basically trying to socialize the use of that terminology within our industry, because it is, as you pointed out, it's so important to be able to monetize, to be able to get taken seriously in the national conversation about energy, et cetera. We've got to start talking in that language. We've got to start collecting information, publishing information in that language, so that we can be like the rest of the cool kids instead of being these strange nerdy folk on the side of the cafeteria, which is kind of where we are right now.
Two more
Yep.
short
So
questions.
I would just add one last comment and then hand the microphone off. I mean, from my humble view, there are standards or technical units of measure. There's vocabulary, there's thinking, and then there's behavior. And the last two are the most challenging to change. But I agree with you, if you're going to have a chance at changing it, the standards and units of measure have to change in order to drive the different thinking and behavior. Thanks.
For folks who don't know, that was John Thomas, president of Water Furnace, one of the largest manufacturers of geothermal heat pumps. We have time for one more question.
Hi. Oops, sorry. Elle Jaworski with PW Grosser. I just wanted to say I do kind of agree with Brendan. We were talking earlier about like the entire mechanical industry and how and like moving that forward. Like as a designer, I think when we collaborate with MEPs to do energy analysis and on buildings and stuff, oftentimes that comes back to us in BTU. And so I think there really just needs to be a lot of collaboration with the designers on the mechanical side and how we analyze these buildings and put out that data to make sure that through the process we're not making crazy conversions that could cause errors as we make the change, you know?
Great. Thank you. Good point. On behalf of the NY-GEO board, I want to say I hope you've had a wonderful, educational, and inspiring conference. You are now released.
So, Bill, I think your Take the British Out could be a way to have a little campaign. Oh, sorry.
Sorry, Zeynep, I have 75-year-old rock and roll music.
So you had fun.
Yeah.
your idea of the kick the British thermal unit out at the 250th anniversary. In December, we had our annual party on the tea party ship.
Oh, wow.
To launch a thermal revolution.
Everybody put a hand on this balloon here.
Great way to have it funny in the show.
Or I'll get you standing with that sign in the background.
Can do all the conversions is
Just one more shot. You guys are, you know, famous here. Can we get it off for you?
Oh,
Up there, just standing.
Sure.
Everybody put a hand on the balloon like it's a football. Stand up. So, I'm no.
What is this balloon?
Does it have
Well,
hydrogen
I
in
sent
it?
a balloon. I sent a deflated balloon to Donald Trump in envelope. I said, think green. So I thought maybe.